Welcome to today's discussion, in which we'll be addressing the topic of bioplastics in packaging. Recently, we've spent a lot of time exploring different conceptions of sustainability and different visions of circularity. There are a lot of voices throughout the industry advocating switching, where possible, away from conventional to bio-based plastics. It's fair to say that this view is also contested within the worlds of packaging and sustainability. Today, we'll be discussing the environmental implications of bioplastics, along with opportunities and roadblocks around further adoption across all of these packaging applications. Hopefully, we'll also have time at the end to answer some questions from the audience. So please do share any questions you'd like to put to our panelists via the YouTube chat for this stream. So without further ado, let's introduce those speakers. I'm delighted to be joined by a panel representing some leading voices in the world of bioplastics. First of all, we have Hasso von Poggerl, who's MD of the industry body in European Bioplastics. We have also Gary T, who is UK Sales Director at TIPA, which is a compostable flexible packaging specialist headquartered in Israel. And finally, Andy Sweetman, who is Head of Sales and Marketing at Futamura, which is a global specialist in compostable films. Hello, everyone, and welcome. Thanks for joining us today.
Thank you.
Thank you.
So let's start by talking about the sustainability credentials of bioplastics. One of the frequent criticisms that I encounter, at least with regards to compostable or biodegradable bioplastics, and I guess it's important to point out at the outset that bioplastics is a very broad term, and it also includes bio-based recyclable equivalents to conventional plastics. But let's restrict this question at the moment to compostables. The criticism is that they aren't really circular because the material's going back into the environment rather than being recovered by the system and recycled. Isn't it better to recycle materials than to compost them? Hasso, could I ask you to respond to that?
Sure. Well, maybe first I would like to do away with the misconception that composting is not recycling. Composting is recycling. It's only a different form of recycling. It's organic recycling. But that said, coming back to your question, whether mechanic recycling, I think this is how the average listener will probably interpret recycling being as mechanical recycling. Whether that is superior to composting is actually not the real issue. The real issue is, can a packaging be recycled mechanically? If it can be recycled and if it is being recycled, it makes sense. But already today, we have a lot of packaging collected out there, which is in theory and technically recyclable, but it's not being recycled for many different reasons. One of them being that it's not economically viable. And then you have the case that these are at best incinerated with energy recovery, at worst they're being landfilled. And then you have those plastics which are not really recyclable because in many cases they will be contaminated with food waste. And this is where composting comes in as the far better solution than trying to recycle it, which is not going to happen, or incinerating or landfilling it. So it's not a question whether recycling, mechanical recycling is superior to composting. It's a question with which application does which end of life make sense.
Okay, thank you. Andy, is there anything you'd like to add to that?
Yeah, I think what I'd probably add to that is if you think of the natural cycle of a plant, it grows from soil, it has its lifespan, and then finally it dies and it goes back to soil. That's the natural circle. And in fact, that's what a renewable and compostable bioplastic material is as well. We're growing the raw materials to deliver these materials. They're having their functional life, and then we're taking them back to soil through composting. So they're absolutely the embodiment of circularity.
Okay, thank you. So another of the concerns that are often raised about bioplastics, again, when we're talking about biodegrading materials, is the concern around littering and what happens to it, how quickly it degrades, what is its impact on the environment. Obviously, we've got a lot of talk at the moment about ocean plastics, microplastics, etc. How does the compostable packaging material answer these concerns? Andy, could you continue on that?
Yeah, I mean, I think we can have a whole conference about the subjects of different forms of biodegradation very, very easily. But
I recall very long discussions about this at European Bioplastics conferences.
Indeed. I think that the key is in, the answer is in the word compostable. What we're talking about here is about managed organic recycling of waste, including food waste, garden waste, and compostable packaging waste. So we're not by any way, shape, or form suggesting that these are materials that solve the litter problem. The whole point is to avoid litter in the first place through a managed process. And that's what this is about. Proving that materials are truly compostable, using them in the right applications, helping get more food waste and/or garden waste back to organic recycling by the use of these particular materials, and absolutely in no form whatsoever an excuse for littering.
Okay, thank you. One of the other sustainability questions that we've been certainly at Packaging Europe trying to raise on the agenda and promote above, above some of the things that have been dominating so far, is the issue of carbon footprint. And obviously, we're going through a climate crisis that is possibly, a greater worry than even plastics in the environment. How do bioplastics compare to conventional plastics when it comes to the carbon footprint? Hasso, can you comment on that?
Yeah, sure. Well, I think it's actually pretty down to earth and easy to understand that if you use renewable raw material for the production of plastics, it's a different story than using something like oil, which has been in the ground for millions of years, and it takes a lot of time to reestablished. So using something like an annual crop that regrows every year makes sense in every word. And of course, it reduces the greenhouse gases that you are emitting for the production. So I think it's a fairly simple answer to that, and no big secret about it.
And in terms of the energy inputs for production?
Well, I guess in many cases, but I'm not, since I've never produced myself, I have no idea how exactly this is taking place. But as far as I know, that should be more or less comparable. The real savings is in the material that you're using. And often those people who are making bioplastics, bio-based plastics, often also use bioenergy to do so. So in any sense, it's a reduction of the greenhouse gases in the production.
Certainly from TIPA's point of view, we utilize existing extrusion equipment. So our materials will be produced on conventional machinery. So we've not added a complexity to that. We've utilized machines that are already there. And the energy consumption is in line with traditional plastics in terms of that.
Okay, thank you. So I guess the final sustainability concern that is sometimes articulated about bioplastics is the worry that they could divert land use from food production, or even if there's growing demand on land use driven by bioplastics, that they could even drive further deforestation. Is this something that you would say stands up to scrutiny, Hasso?
Yes, absolutely. I mean, this is something we're faced with very often indeed. And I think if you go back to the real numbers, if you don't just discuss it from out of gut feeling, but really look at the numbers, it's astonishing to hear this allegations, because if you look at the global agricultural area, around 70% of it is used only for pasture. So for the production of meat at the end of the day, for our diet. And from the other remaining 30%, 26% again is used for food and feed, and only the remaining 3 to 4% are actually used for biofuels and for the material use. We really put down the numbers and checked how much of the land use is actually attributed to the making of bioplastics, even when we are extrapolating how it's going to look like in maybe 5 years, we're talking about 0.02% of the agricultural area. So I always like to make the kind of annotation, if each of us would stop eating a steak once a week, we wouldn't need to discuss this whole issue about bioplastics allegedly diverting food from the table. It's not an issue, not at all.
Okay, thank you.
Maybe I could just add to that,
Yeah.
actually. The other thing that you can do is talk to the suppliers of the different materials in terms of what do they have as sustainability programs to substantiate the sustainability of their raw materials. So in the case of our NatureFlex product, for example, it's principally a forestry product. So we look to certification from the likes of FSC and PEFC standards, which measure all of these particular aspects and confirm that's the case. And there are similar types of program for other types of raw material sourcing. And that's a very important thing. It means customers can have independent verification of the kind of claims that manufacturers are making.
Gary, did you want to jump in?
Yeah, I was just going to add in, our current source of carbon is sugarcane and starch. But looking forward, and TEPA's doing a lot of work looking to the future, is that we're looking at other potential sources of carbon, like algae, or even carbon capture as well from CO2. So where we are today isn't where we're going to be in 5 to 10 years' time. So yeah, as the industry grows and the volume increases, we're going to become more creative about where we capture our carbon from to obviously use in our polymers and to our materials.
Okay, thank you. Well, let's move on then from speaking about the sustainability credentials of bioplastics to the opportunities within packaging applications. Let's start with Gary. Where do you think are the biggest opportunities for market growth within packaging?
Sure. Yeah, for us, I think we're going to look to fix some of the biggest problems. I think Hasso touched on this earlier. Some traditional plastics are easier to recycle than others. So, for instance, there's a lot of complex laminates that are used in the industry for giving the right shelf life and protection to food items. They are by nature complicated. So they are going to be very difficult and difficult economically to recycle. So for us, we have a broad range of laminates that have very high barrier properties that enable you to still enjoy the shelf life that you currently have and the functionality, but are still certified to be industrial compostable. So for us, that's going to be a key area. Other areas is where we use the characteristics of the materials that work in our favor. So for instance, our polymers are quite porous to moisture and to oxygen. So when we use them differently to the high barrier structures. So for that, we can start to look for shelf life extension for produce. So we're actually looking to add life rather than take it away. And by that, we can start to help avoiding food wastage. So there's some really exciting work we're doing currently in that area as well. So for us, plenty to look at going forward.
Andy, could you speak about that as well?
Yeah, maybe just to build on that. I think Hasso made the point again earlier on in terms of recyclability where it's viable. We have this expression in English, horses for courses, and I think that applies very, very well to the bioplastic situation. If you've got a good recycling system, and let's take a carbonated drinks bottle, it's polyester. We have a polyester to polyester recycling system. It ain't broke. Don't fix it. Leave well alone. We don't want to see biomaterials going in to those particular areas. Let's take the flip side to that, and we like convenience. I'm a great coffee lover. I have my capsule machine. Why would I consider using a conventional plastic for my capsule when I've got compostable plastics that can do the job with the same functionality, the same barrier performance, and that means that the capsule and the waste can be composted rather than ending up with the worst possible scenario of a plastic container with compostable waste inside it. So what are the best applications for these kind of materials? That's where we want to be, solving difficult problems rather than creating new ones. And that to me means anything where you've got food waste contamination, Maybe it's like a ready meal, a prepared meal, or maybe it's a French soft cheese, for example, where the soft cheese is on the wrapper. You're not going to be able to recycle those kind of things in any situation whatsoever, but take those towards via food waste diversion through to composting and so on, and you solve that problem. So think about the application in mind, and then bioplastics are really interesting in those particular areas.
Great. And if we think about the technical advances that are undergoing in bioplastics, and I guess the challenges that we want to rise to meet some of these specific application conundrums, are there any particular areas of innovation, recent or sort of ongoing, that you'd like to pick out? Gary, can you go first?
Yeah. Well, I think we do work very closely with Food Tomorrow, to be fair. So our materials are designed to emulate currently polythene and polypropylene in characteristics, but chemically very, very different. But we do benefit from working in collaboration with cellulose. It enables us to bring in extra barrier to our materials, which gives us then the oxygen and the moisture barrier and the light barrier. So, for instance, we can make a fully functional, here's a, not too exciting, but this is one of our high barrier pouches. So that's using cellulose in there for barrier, and 302, which is our layer for the sealability, strength, and puncture resistance. So we're all the time trying to encompass as broad a range of the current market as we can, so that compostables can be a choice in many, many areas. We're also looking to evolve our materials. So for instance, our 302, we're looking to add a little bit of extra moisture barrier to that. So that's going to make it more applicable, more closely match a polythene. And then that will allow us to enter into more of a traditional polythene market as well. So that's an exciting development we're currently working on. But certainly what we have on the shelf today is Gen 1. Gen 2 will be coming next year, and there's lots of work that's going on there. And I know the guys are working on Generation 3 beyond that. So yeah, there's a whole pipeline of products we're working on going forward.
Okay, great. And can you comment, Gary, on what the direction of those future generations are? What are the properties that are going to be extended there? Yeah,
we're running a tightrope between barrier and composting. We will never be as good as aluminium foil in terms of barrier. So we've got to get close to it, but without losing the compostability. So that's a key element we're working on, is adding the barrier either through an additional layer or through the chemistry of our material. And then that's just broadening the appeal of it to different markets, and potential even further shelf life increases. Also trying to move materials more into a home compostable environment as well. Currently laminates are typically industrial compostable. We can make home compostable laminates. So for us, that's very much going to be the next stage for us, is to roll that process out.
Thank you. Andy, could I ask you also about the sort of cutting edge of innovation in bioplastics? Where do you see the big advances coming?
Sure. Well, I think first of all, I'd echo very strongly what Gary's just said. It's about barrier performance. It's about mimicking plastic films, particularly laminates, have unbelievably good functionality. So we have to try and match those properties. What I think is really interesting, and Gary was touching on this, when you put a laminate together, you want one material which is heat resistant, easy to print, has the right kind of barrier properties, and you want to associate that with a really good sealing film. And that's where these things come together. And what to me is exciting is when we start to see, for example, now the first home compostable laminates that are packing difficult products like meat and bacon. I mean, bacon packs are typically polyamide laminated to polyethylene, fundamentally incompatible from a recycling point of view. And we can do those now by combining these different materials, so a NatureFlex and a TEPA material coming together and doing that kind of thing. So there's real synergy between the different compostable materials that creates that complementarity, and yet you're still, as Gary touched on earlier, using the same kind of packaging machines, the same lamination and printing machines. So you can switch out of the conventional and bring in the bio.
Okay, and are there limits at the moment around sort of ultra high barrier applications that bioplastics can't quite match the most effective high barrier conventional
Yeah.
plastic films?
Yeah, I can add something on that. We have our limitations and we have to work within those. So compostables by nature are going to be damaged by moist, long life products. So for TEPA, and I think we're typical of the sector, we're not going to be going near retort or pasteurized long life products. That condition in the pack is just going to accelerate the degradation of the material and starting the compost process. So it's about knowing about your strengths and your weaknesses and then working within those, but at the same time pushing the boundaries of what you have to enable your possibilities to increase. But I do think there's certain areas that the buyers will struggle to go into, certainly the compostable bio sector.
Yeah, maybe if I may, I could add something to that as well, because we're just now talking about only the compostable area. We are also the bioplastics. We also have those that are only bio-based, but not compostable. And there, indeed, you do not have these problems. You have actually, in some cases, you have new polymers which are superior to existing ones. Just for example, the PEF made by Avantium, which is superior actually to PET when it comes to barrier properties. So you could actually make the same kind of bottle for carbonated drinks with less material to have the same property as PET. It is recyclable along with PET. And once you actually have the amount in the market where it makes sense to actively collect it for its own recycling, that is also possible. So indeed, bio-based versions of either conventional plastics or drop-in solutions or new solutions are actually in many cases equal, if not superior, to the conventional ones.
Okay, thank you. Andy, do you want to jump in?
Yeah, just a final comment, actually. I think Gary touched on this earlier, where you're talking about wet products, absolutely a limitation today. Now, R&D work goes on, so we might see some of these things come into the marketplace, but it's a very, very difficult area. One of the things we are seeing, though, is actually some brands understanding that and adapting the products they've got to meet that. So one example would be sachets which might have had a liquid in at the moment in high barrier conventional plastics won't work in compostables. But what the manufacturers are doing is they're moving to a refill type option with a powder or a granulate inside. So you simply add the water at the point you want. So we've got quite interesting developments in stick pack formats, which replace those kind of source sachet ideas as well. So the creativity can be as much at the brand and food producer as it is at our level.
Okay, great, thank you. All right, so we've spoken about sustainability and opportunities. Clearly, this is a sector that's growing, and maybe Hasso can give us some insights into the speed that it's growing based on European bioplastics research. But let's think about those growth opportunities and any roadblocks that we think that the industry needs to navigate around in order to achieve that growth. First of all, I suppose consumers are a key factor, whether they accept bioplastics or not. Hasso, can you shed any light on general consumer attitudes to bioplastics?
I guess it's like with every other issue, there's the pros and cons, and there are those people who are against and those that are pro bioplastics. I think, said simplified, is those that are well informed are indeed in favor of bioplastics because they know that bioplastics can deliver when it comes to functionality, and they can deliver in different forms of end of life. And those who are not informed, they tend to be skeptical towards bioplastics. For one, the issues we touched upon earlier, the food versus fuel discussion for one, or the question whether something is actually really completely compostable. If it says so, does it really work in composting industry? What about the issues of littering? Do bioplastics, are they a solution for littering? And unfortunately, many people expect them to be, but of course, as Andy said earlier, they're not. They're not designed to be littered. They're designed to be collected just like all other plastics. So I think the average consumer, if he is more or less well informed, is in favor of bioplastics, and those that are not well-informed, they often have a tendency to be skeptical towards them.
Mm.
But the numbers are indeed growing. They could be growing faster to my mind. If, but we'll come to that later probably, if the environment for that, the legal environment would be more favorable. But indeed, bioplastics is still growing. There's quite a few polymers out there which are being demanded for, where the supply just can't keep up with the demand. So actually it is working well.
Okay, great. Gary, I understand that TIPA has been conducting some research into this question recently.
Yeah, that's right. We did a poll. It's a UK poll. It was actually during the virus, so it was during the pandemic. And the headline numbers is 85% of consumers believe that compostables should replace plastic for food packaging. And interestingly, 58 will be willing to pay more. And 67% expressed concerns around the increased plastic waste during lockdown. I think we're all been very aware of the number of face masks, etc., that are now being littered. So it's littered, sorry. So there's obviously, you know, the customers care, the consumers care. You know, I often talk to my friends around, you know, what I do, and their answer to me is, why isn't it all like that? Why, you know, composting sounds such a great solution. So I think the person on the high street definitely gets it, and they favour it. It's just how we then roll that out and to take it to market really is the challenge.
Okay, thank you. So another potential roadblock, as far as I can see, is infrastructure for end of life. We've talked about composting, and obviously there's both industrial and home composting. And as anyone interested in circular economy within Europe knows, obviously we have a very fragmented infrastructure for recycling, classical recycling, not just on a national level, but you know, in a country like the UK, every local authority has its own different systems in place. And I guess we have a bit of a chicken and egg problem, haven't we, in terms of market growth requiring the infrastructures to deal with compostables, but also that infrastructure waiting for the growth in volume to make investments worthwhile. How do you see that problem and the solution to it, Hasso?
Well, I think indeed creating the right infrastructure is absolutely key to getting this whole system working. I mean, the European Commission, as of 2023, you will have a separate collection of bio-waste to be mandatory. So this indeed could or should help build up the infrastructure for the collecting of bio-waste. And that should indeed also help for biodegradable plastic, for compostable plastics, to play an even bigger role than they're playing now. So this is a good step forward. What I think is missing, indeed, as you mentioned in your introduction, is that it's very diversified, not only within the European Union and each member state, but even within the municipalities. And trying to get something comparable on the whole European level would indeed be very helpful. Because, for example, if you look at Italy, where it seems to be working rather well, you have not only the infrastructure, but you also have legislation adapted to that infrastructure around. So, for example, all carrier bags below 100 micron, which is actually a pretty thick bag, needs to be certified compostable. And that makes extreme sense, because that way the composters are willing, or a lot more willing, to accept plastic bags, knowing they will be compostable in their facilities. And this is exactly the opposite that you have in Germany. In principle, it's allowed to use those bio-waste bags to be collected in the bio bin, but a lot of composters fight it because they are afraid if they open their facilities to plastic bags, they will be swamped with contamination with conventional bags. And this is why it's not only important to have the right infrastructure, you have to have the legislation adapted to that infrastructure to go along with it.
Thank you.
I think if I could just add one thing to that. I always get frustrated with the use of the word infrastructure when it comes to this, because it sounds like there's no composting. I can't talk for every country in the world, but pretty much every country has around 35% of the waste that it creates being organic waste, be it municipal, food waste or whatever. And just taking the UK as an example, there's already over 200 composting facilities that can take compostable packaging, and over 50 of them already are actively taking compostable packaging. So there's not a lack of infrastructure at the end to compost. What there really is this identification and recognition. And that's something that we're quite involved with, working with governments and stakeholders to say, okay, well, how do we make sure that we recognize the material is compostable, it's got the right identification, the consumer can understand it, the collection agency can understand it, and the composter. And then exactly as Hasso's saying, with the food waste collections being mandatory across the whole of the UK and the whole of the European Union by 2023, there's your easy vehicle for the consumer to get those materials to the right place.
Yeah, thank you.
If I can just add on that as well, that's obviously our vision as well, is that compostables goes in with an organic waste collection, food waste. It could even be garden waste. What we've done, certainly in the UK, is engage closely with certain composting facilities so that we're not somebody that they don't know and understand. So we talked about doing composting trials, explain what our materials are. We've taken retailers and customers to see these facilities. So they're massive scale operations and they can handle thousands of tons of waste a year. So it's quite ironic that we are classed as not having an infrastructure, yet we have quite a well-developed multi-site composting capability in the UK and around the world that is ready for this. But they may need some education. They may, we can't just turn up and expect them to welcome it with open arms. And as Andy says, clear labelling is really important. They need to know what they're receiving is the right type of material, it's certified, and it isn't going to create a problem for them further down their composting process. To be fair, they have a big enough problem already removing the traditional plastics that makes it into that compost waste stream. I've personally seen the amount of effort they have to put in removing the old crisp bags and polythene bags from compost before they then can end up with a quality product that they can sell. So yeah, they're a very engaged group that we need to work closely with. Okay.
And does all of what you've said imply that home composting is a more difficult end-of-life route to develop?
It's a harder test to pass because the process is done under less strict conditions. So the temperatures are lower, the manual intervention is less. So the test method is harder to pass. So yes, it's harder to get home compostable spec than industrial. We're trying to move as many of our materials to home compostable as possible because it naturally means that in an industrial environment, they will compost quicker. And it also means we shouldn't forget that the consumers can still make a choice. If you have a garden, I tell people for £20, you can go to B&Q and buy a black bin and you can be composting this afternoon. So you can start to take some responsibility for your own waste management. And if you put the right material in there and you manage that compost bin, then you will genuinely home compost that packaging. Just worth adding as well, Cray in Ireland is doing some amazing work. Ireland seems to be exceptionally progressive in terms of composting and packaging. And they're now starting to allow compostable packaging in with their brown bin collection. They're starting to do their own low certified materials that they're testing themselves. So the benchmark is EUM 13432 to allow it to be tested. They will then further test it and then award you a certification afterwards that you can then print on the packaging. So I have to say Ireland seems to be leading the way in terms of their progressive thinking on this.
Okay, thank you. Hasso, you alluded just now to the European level policy and how it impacts on bioplastics. Overall, how do you see the regulatory environment as either a supporter or inhibitor of the growth of bioplastics?
Well, as in most issues, it's diversified. So what we have on the level for research and development is very good. The European Commission is taking a lot of money in their hands to have research and development on bioplastics being done, carried out. The EU 2020 Horizon programs is a very well-funded program, a lot of different projects where research is being done. But then when it comes to the implementation, That's much more difficult. Here you have to distinguish between the different DGs often. So for example, DG Agri, let's just take the mulch films as an example. DG Agri is very much supportive of biodegradable mulching films, which have to be certified to be biodegradable in soil. So we're not talking about composting in this case, but biodegradable in soil. And on the other hand, DG Environment is very skeptic towards that because they are afraid of microplastics ending up in the soil. And despite all the, the proof that we were able to bring them showing that these mulching films really work, they're still very skeptic. So you will find, depending on the department, depending on the person, people who are pushing for favorable legislation, and others trying to impede because they want to have the perfect solution and are not ready to go for better solutions than the status quo in order to someday reach the perfect solution. But they expect bioplastics industry to come up with the perfect solution now, or we stay at where we were at the current moment. And this, to my mind, is the wrong way of going ahead.
Thank you. Gary, did you want to chip in on that question?
I was just going to say, certainly in the UK, the UK Plastic Pact that recognised compostables as a waste management system was very positive for our sector, and that's a great step forward there. I think the UK government supports the bio sector, so I think they're very supportive of our sector and the growth of it, and recognise the value that our sector brings to the economy and will bring in the future. There was a recent poll as well of MPs back in March 2020, and 98% of MPs agreed that compostable packaging alternatives can play a part in the solution of the plastics crisis, and 86% agree that the UK government should invest more in infrastructure with compostable materials. So we do have some high-level support in the UK, which is great to hear. We just need to take that forward in action, and we certainly hope the UK could be sort of the gold standard for the future. But work to be done, definitely.
Okay, great. So we've already alluded to the fact that in some cases demand outstrips supply for bioplastic materials, and obviously with any new material on the market, there's going to be a requirement to scale up production to meet those opportunities. How has that been faring? What are the challenges around it? And I guess, is COVID-19 and this general production crisis and economic caution around it impacting on investments? Hasso?
To be honest, I don't know. From what I've heard from the member companies that I've been speaking to, I have heard no real negative impact regarding COVID-19. And if you look at the development of single-use plastics, which are currently actually growing because of hygienic issues, I honestly don't see a big negative impact through COVID-19 at the moment. Whether this will change within time, I don't know, but currently I cannot confirm that this is indeed an issue. I guess Andy, Gary might be better.
Yeah, no, I would, I think we're seeing increased consumption of traditional plastics. Products that were going to be considered to be unwrapped are now being wrapped because there's a perception that if product is wrapped, it's going to prevent the virus from contaminating the food items. So there's certainly a trend there. I think the message that we've got with this is that you can compost locally, so you don't need to export your packaging waste around the world. There will be centres of excellence for recycling, certainly in Europe. So that's going to mean the movement of waste. Where if you choose to go down a compostable route and you get the things sorted locally, there's no reason why compostable packaging has to travel long distances. It can be done in a local area and managed locally.
Yeah, and I'd say from our experience, COVID has been overall neutral, but in a rather strange way. So for the first period, we had customers desperate to get materials in because they had increased demand. But at the same time, we had one or two sectors. We supply some films ironically into the automotive industry as well as packaging, the automotive industry shut down for 3 months. So for every customer who was doing that, we had one doing that, and the net result was broadly neutral over time. So we don't see that as being a long-term issue for the business. You're right, of course, that demand increases in something of a linear way, whereas capacity is like that. So that is one of the sort of headaches that we have to grapple with, which is how do we phase our investments as accurately as possible, because you need the customers there to pay for the investments and so on. So that's an interesting headache for any business to plan.
Okay, thank you. Right, well, I think we've more or less run out of time for our main discussion, but we've had a lot of engagement from our viewers on YouTube, I can see, and quite a lot of questions that have been put to our panelists. We probably won't have time to go through all of them, but I will try to get through as many as I can. So let's start with this one, which is from Martin Klemescher. Martin asks, if we can use the term organic recycling for composting of bio-based and biodegradables, then can I conclude that energy recovery of bio-based plastics is also a form of recycling? Would anyone like to take that?
I go ahead. I mean, people say that composting is often named as being cold incineration. So indeed, composting a plastic package per se doesn't make any sense. The sense comes in when you compost the package together with the food waste. This is what it's there for. So incineration is, of course, also a kind of a recycling. And I think people tend to forget that recycling is not a perpetuum mobile. So you will not be able to recycle packaging all the time. At some end, the chains become so short that you cannot recycle it any longer. So incineration with energy recovery at the end of the day is indeed the end of life for most packaging. The question is, can you create as many mechanical recycling circles as possible and then only go to incineration, because that makes sense. It doesn't make sense to incinerate something which can be recycled. Only that cannot be recycled should be incinerated at the end.
It's also missing the benefit that compost brings to the agricultural economy. You know, compost is big business. There's thousands of tons created every year that's put back into the soil. So we have permanent erosion of our topsoil through farming and through wind, etc. So if we don't replace that, the soil quality drops over time, crop yields reduce, and we have other associated things like flooding. So to replace that topsoil is vital. So composting compostable packaging combined with food waste collection, which is a key connection, enables that to happen. Then you start to put compost back in the soil, which adds carbon content. It aids moisture retention. It reduces the reliance on artificial fertilizers, and it'll aid and increase the crop yields in the future. So to burn it, it's a shame. You know, it can do so much a better job if it is allowed to do, you know, the proper cycle that we've designed it to do.
Thank you. Right, let's take a second question. This one is from Anna Pellizzari. She's picking up on the points that we briefly touched on in the discussion about the reluctance of composting plants sometimes to accept biodegradable bags. And she says that, yeah, composting plants are not that eager to compost bioplastics in her experience. And in some cases, they would even remove them from the process from fear that they would compromise the recyclate, or the composting. How can this problem be solved when it's encountered?
I've personally been to compost sites. I'm pretty sure Andy and Hasso has as well. And the idea of removing the packaging when it arrives in the mass that it arrives in, I think is very unlikely. It is a big multi-ton drop of wet mess, basically, that turns up on the platform that then needs to be mulched and then turned into the material ready for composting. So if it's arrived at the composting site, they may be able to pick off residual stuff that is on the surface, but they're not going to be going very deep into that mass. It's pretty much impossible. So the the decision's really made by the consumer at home or the business that is sending its waste to that facility. Largely, it'll then go through the composting cycle. Obviously, compostables is composted, so that will disappear through that process. But it's the residual carrier bags, crisp packs, etc., that end up in the mass at the end that are then finally removed and sifted at the very end of the process, not the beginning. So that's my personal experience of it. So
yeah, and just
clear labeling for the consumer and that decision being made in the home or the business is the start of it.
exactly, just to build on that, and Gary mentioned the example of Cray in Ireland before. Once you've got a system in place with simple identification and messaging that's recognized by everybody, you can make sure you get the compostable packaging through the right stream. The worry is not the compostable packaging in compost. The worry is the misthrows of conventional that cause that.
Well, that's what I tried to mention earlier when I said that the legislation has to be adapted to the infrastructure, like in Italy. If you want to avoid the chances of misthrows, if you make it compulsory that all bags below 100 micron, for example, are biodegradable or have to be certified compostable, then this is not an issue any longer. Then the composter doesn't have to try to extract plastic already in advance, and you can be more or less sure that there's little plastic left after the composting cycle.
Okay, thank you. So we have a question from Karolina Wiszomirska, who asked, is compostable packaging in cosmetic applications safe and possible?
Maybe I'll take that one first. Yes, it is. Obviously, there are going to be particular requirements in the cosmetic industry that you need to make sure you fulfill. But if I give you one example, so there's a manufacturer of bioglitter. So there's been a lot of focus about, is a glitter a microplastic? And well, fundamentally it is, unless it's bioglitter. So you can produce that now from compostable materials. It's active, it's in place, and what the manufacturer of that particular product is doing is making sure that they're not just compliant with the composting regulations, but they're also compliant with the cosmetic regulations as well. So yes, you can put the two things together.
Okay, I suppose thinking more broadly about cosmetic applications, one of the challenges may be if it's more of a liquid product that that would be challenging to hold for the barrier properties that we were talking about.
Yeah. It's going back to that wet product. It can trigger the compost cycle if we're not careful.
Yeah. Okay, great. So we have a question here from Gordon Bardas. Gordon asks about impact assessments on biodegradable plastics, and in particular he's asking about the experience of countries such as Italy, which have more widely used biodegradables than some of the other markets. Do we have any insights on the impacts that have been recorded in those countries?
I'm not quite sure what you mean with the question. Are you looking about life cycle assessment, like these kinds of impacts, or?
I guess that is, yeah, I suppose, but also drawing on the larger volumes of usage within those countries.
Of course, a very large and complicated field, because the life cycle assessment, if done correctly, in this case, when it comes to packaging, also needs to take into consideration the packaged good, because looking only at the packaging itself doesn't make any sense, because if you compare a compostable packaging to a conventional one, from a life cycle point of view, the conventional one may look better because it's already there on the market for much longer. But this is a wrong way of looking at it. You have to look at it together with the packaged good to make the sense, because if you have a packaged good in a biodegradable packaging where you can make the lifespan much longer, then the LCA will look much better. So it's definitely wrong to look at it only in separate ways, but you need to look at it more holistic.
Maybe just to add to that, you mentioned Italy briefly, and I believe that when Italy mandated the use of compostable bin liners in certain regions, they saw a 30% increase in the yields of organic waste going to composting plants, partly by less sort of loss through the chain, because it's nicely bagged up in the right kind of bag, but also, of course, some of that waste is wet, sticky. So as you were getting rid of a plastic bag, you were getting rid of a load of organic waste at the same time. You no longer need to get rid of the bag with a compostable bag. So I think it was something like a 30% increase in yield that they reported.
Okay, thank you. So we have a question from Sripana Das, who asks, does the trend towards monomaterial packaging, I guess we're talking about conventional plastics, reduce the market for laminates? And does that have implications for the demand for compostable laminates as well? And I guess we could frame this in a broader, context of, we know that conventional plastics are, working very, very hard to drive a fully circular economy with universal recycling, etc. Does that reduce the case or the demand for bioplastics?
Yeah, I can talk about that. So yeah, there is clearly a big trend towards monomaterials and trying to make pouches, etc., out of basically polythene and add functionality back in. And they're trying to simplify their waste stream down, so they're dealing with ideally one material, which is totally understandable. They've got a challenge, they've still got to fix this. They've got to come up with a system that works, that delivers, economically it works as well. And they've got to find an outlet for the recycler, which currently isn't food grade approved. So I'm not quite, we can make assumptions where this will go, but there's a lot of unanswered questions on that I know they're working hard at, and they will come up with some solutions. So yes, I suppose the availability of complex laminates to compostables does reduce if that sector's successful. But it would just depend on how tolerant they're going to be to high levels of food contamination on these pouches, etc. So, like any recycling process, the cleaner it is, the less complicated it is, the more successful it will be. We don't mind that. So we can have complex laminates that, as long as they're certified, are still compostable. If they're contaminated with food, they don't need to be washed. We want the food. So again, we simplify the problem really by right down. So you don't need to wash it, just put it in with the food waste collection when we're allowed to, and it will then go to the facility for composting. So yeah, it's a changing piece. Things will happen on both sides, but it certainly doesn't stop our enthusiasm to provide our solutions. I think the other benefit we're experiencing currently, if I can just add, is machinery is being modified in packing houses to run the polythene. Well, that actually helps us because some of our material benefits from the modifications that they're making to run monopolythene to run some of the biopolymers as well. So that's quite a nice benefit we're getting currently.
I think people tend to forget that laminates weren't developed just for the fun of it. They were developed to add specific properties, to add specific functionality. And with that, you were able to reduce the amount of plastics being used in packaging by 10, 20-fold, because you could make very thin packaging with at least the same, if not even better barrier properties than you would ever achieve with a mono material. So again, like I said in the beginning, you always have to look at the intention behind the different kinds of packaging to really be able to assess its benefits. And from an LCA point of view, if you reduce the amount of plastics used, that also has a very big impact. So I think this should always be kept in mind.
Okay, great. We have another question here from Keith Binding. How significant a barrier to adoption are the more demanding operating parameters of bioplastics, for example, in injection molding compared to traditional polymers? I think we have someone's dog in the background, which very welcome to join us on the panel. Yeah, so we're talking about a more demanding context, such as injection molding. Is that one of the more challenging areas to apply bioplastics?
Well, I guess you've got flexible packaging experts rather than rigid packaging experts on the panel today, but I think it's about the polymer. The answer will vary depending on each specific polymer. and there are a number of bioplastic polymers that you would look at. But I guess if you look at the number of bioplastic trays and bioplastic coffee pods and things which are out there now, it shows that with the right equipment and the right conditions, you absolutely have rigid packaging solutions available with bioplastics.
Okay, thank you. I'm going to take two final short questions, and unfortunately we've run out of time to do any more than that, although we still have quite a lot of interesting questions coming in. This one is from Paula Carqueles Moreno, and she's asking about anaerobic versus aerobic composting, and whether there's any preference from a sustainability point of view, and whether there are any sort of particular challenges that are associated with one against the other.
I think it's actually a really good question, and touches on something we were saying earlier on in terms of benefits. One of the things that you see in a number of countries is that either anaerobic digestion or aerobic composting are the chosen model. If we look again to Italy, then they've got it right in the sense they've realized that it's not one or the other, it's potentially both together. So just to throw a couple of stats at you, if you took a ton of organic waste and you took it first of all through anaerobic digestion, and then you mixed it 50-50 with garden waste in aerobic composting, you actually end up with a triple win. First of all, you save about a ton of fugitive CO2 emissions. You'll then generate something like 850 litres of biofuel, so renewable energy. And then you've created a fertilizing compost at the end, which, as Gary mentioned earlier on, improves plant yield, reduces water loss, improves structure, and displaces fossil-derived fertilizers. So I think that's a really, really important message for all of us across Europe, is stop seeing AD, anaerobic digestion, and aerobic composting as one or the other, and put the two together.
Okay, great, thank you. And we'll take a final question from Aditya G, who has asked about paper laminated with biocompostable films and how that would behave in a recycling stream. And I suppose we can also ask about how that would impact within a composting stream.
I've got a little bit of experience with this, so I can share this. So, you know, if from TEPA's point of view, if we make a laminate, we don't have such a laminate currently, but if we did, it would have to be certified compostable. So for us, that would be its end of life. If it went for repulping, then you're in a complicated area. You've got to try and remove this inner ply from that paper. There are rules coming in now about the thickness of the additional layers to the paper or the board, which the recycling industry's rightly imposing, because they need to try and manage that process. And there's a lot of additional layers being added to paper now to improve functionality and barrier, etc. So it's being done for a good reason, but it's definitely complicating the process. But in reality, are they going to, you know, they're going to try and remove that inner ply layer and then try and recover the fibers, but it's obviously going to make life difficult. I think in some ways they're sort of meeting the requirement, but ideally it needs to be liner free, really, as some description. If it was combined though and it was certified compostable, then you could obviously return that board or paper pack into a composting system and then recover it through composting.
Great, thanks very much, Gary. Well, unfortunately, that's all we have time for in terms of the questions. For those of you who wanted to engage with our panelists and we didn't have time to ask your questions, we will put a link on LinkedIn to the final edited video, and we'll tag our panelists within that. So if you'd like to follow up and engage with them afterwards, then that will be an opportunity to do so. It remains for me to give a couple of plugs. First of all, if you've enjoyed this discussion, I would love for you to subscribe to Packaging Europe via our website and also to the YouTube channel, so you don't miss any future discussions of this sort. And secondly, I'd like to mention again that throughout October and November this year, we're going to be hosting a virtual Sustainable Packaging Summit, including the Sustainability Awards ceremony, where we'll be revealing this year's winners, including a category of bio-based, so we'll be interested to see who emerges victorious within that area of technology. Watch out for the details of that, and we hope that we can welcome you, our audience, to those sessions. Finally, thank you very much to our 4 panelists, well, 3 panelists, including myself there. I can see 4 faces on the screen. Thank you very much, Hasso, Gary, and Andy.
Pleasure, thank you.
And thanks very much to our audience for listening. Goodbye.